Today I'm going to talk about how potentially a database for AI applications should look like. Let me just figure this out, how this next, okay, great. So my name is Davit, I'm the founder of ActiveLoop, and we are building a database for AI. So before starting the company, I was doing a PhD at Princeton University, working in the connectomics lab, and the problem that we were solving is that we were taking a 1 millimeter volume of a mouse brain data, slicing into very thin slices, and then imaging it using electron microscopy, and our goal was to reconstruct the connectivity of neurons inside the brain. And the problem or the challenges that we were facing was that we had this 1 millimeter volume of a single mouse brain, and it was 100,000 by 100,000 by 20,000 pixels, which is a petabyte scale data set sitting on top of AWS. And our problem, this processing this data on the cloud, was costing us a lot of money, and we had to think from scratch how the optimization we can go from spending millions of dollars on a single pass to actually a couple of $100,000. And apparently, not only inside our lab, but also across the industry, 1/3 of the machine learning projects are failing because of having no solid data foundation. And this is a kind of a history, what happened about while the databases or data storages have been developing. And we can see from Oracle days till now, we have been building all this data infrastructure specialized for running a lot of transactions or running a lot of analytical queries. But since past 10 years, what happened is that because of deep learning revolution, we have been able to extract business valuable insights from unstructured data, like images, video, audio. But none of this storage layers actually is specialized for that. And more than that, over the last, I think we have been addressing this issue over and over again, is that of the data that's generated today is actually in unstructured form. And you can only even see just the TikTok graph of the videos, how many of them got generated, and surpassing all the other large data content generation platforms. And now the problem is how we can make sense out of it. So I'll skip this slide. I think what database AI should itself provide you is having a very simple API for data scientists especially to be able to create, store, and collaborate on AI datasets of any size. We help also like rapidly transform this data and then stream to the training process directly and instantly explore and visualize it for datasets for AI. And all this for you to be able very cheaply and affordably create AI-first products much faster. So what is happening today is, let's say you are starting a data science project on your laptop. You have to go and manually copy this data set either from AWS S3 or from some Google Drive to your notebook, and then start running your Jupyter notebook and start processing it. Or you're on the cloud, the same thing should happen there. Or even if you're doing a multi-GPU training job on the cloud, each of your machines should go manually copy this data, wait until the data has been synchronized, and then start doing the processing itself. And this all works great if the dataset is small, but even if you get to the terabyte scale, not even petabyte scale, then this becomes a bottleneck because now you have to wait until this data is getting copied before you start the processing of your training job. And what we do differently, or what we suggest to do differently, is actually instead of you manually going copying this data, similarly what, I don't know, 30 years before you're going and buying these DVDs and then plugging into your machines to watch a movie, now you can actually stream this data to these computing machines, and then while the training and processing is happening behind the scenes. And that's like kind of a Netflix for datasets. So what is the kind of a secret behind the scenes is what we do is that we take all your unstructured data, let's say you have 1 million images, and then you have also 1 million labels, separating on them files, and either they are stored on your local file system, or they are stored on your AWS S3 object storage. We take this data and then represent them as n-dimensional arrays, or so-called tensors, that are very efficiently represented on AWS S3 or an object storage, so that we can stream this data to the computing machines as if this data was local to the machine while you're running the training process. And the way it will look like is that now your 1 million files will look like as an in-memory 1 million by 512 by 512 by 3 array. And then you will also have the labels 1 million by 1. And deep learning simply becomes now training a model from one tensor to the other tensor, like image tensor to the label tensor. And what we have seen working, collaborating with the Google RAIN team is that they have a 2 terabyte data set, which is Google Object-Oriented, I think, data set that takes an average data scientist 40 hours to access this data set, unzip the files, understand their API, finally load the TF record files to the TensorFlow, and then now, great, we have spent 2 days to be able to get started just to train a single model or to understand what this data is about. And with us, what we do offer is that you can just install our open source Python package and then point to a data set that's either stored on your local storage or on, let's say, on Google Cloud Storage, and access the same data set in a matter of seconds. And while you are loading the data set or while you are working with it or training a model, behind the scenes, we go and fetch this data set native to your deep learning framework to train these models. So what we also do have is a visualization method for the same way as we stream the data set from the storage to your computing machine to train the model. At the same time, we can also take this and then put it on the browser and stream the data set for you to visualize it. And the same thing we can also see, like this is the ImageNet, which is one of the iconic computer vision data sets. Now it's already pretty small, it's 150 GB data, but still you can use your browser instantly and then being able to visualize this. And more than that, we also have built a query engine. Still it's fast, you can run queries on top of this data set and then being able to quickly filter, slice, and dice the data set for your training models to be able to run it. I think Arjit mentioned about the importance of the open source, so I'll not spend too much time. We have built this, like the dataset core in open source, and feel free to go and start us on GitHub. Multiply, a year ago, it has been trending #2, I think, on GitHub repositories across all of them, and #1 in Python languages. And there's a small consulting company naming it top 10 Python ML packages. I think the main core of this is that we are building a vibrant community of data engineers and data scientists to help us to build and shape the future of how unstructured data should be stored and processed. And I think what we are focused on is like TensorFlow, PyTorch, and then other libraries did a very great, awesome job on optimizing the compute or the performance on the accelerated hardware like GPUs or TPUs. And now the bottleneck is being able to take this data from where it is to bring this to the deep learning frameworks to be able to very efficiently process that. And that's what we are focused on solving. So yeah, if you have any questions, happy to answer now or happy to be there to answer later. Thank you.
Thank you so much, David. This is really interesting. I was wondering if there are any interesting application of using this DB for search, especially that nowadays we're using a lot of semantic embedding for search. And also, what is your personal favorite application of this DB?
Mm-hmm. So let me answer the first question. So for search, especially like if you're operating on top of embeddings or vectors, there are a bunch of very good and optimized for embedding search or vector search engines. I think we are not a search engine. We are more on a side of the, you can think of it as Parquet for images or videos, where each column is as an n-dimensional array. And then on top of that, you can actually build your own search engine that runs it very efficiently. I think currently the state of it is that you can represent the data, and then our #1 use case is stream this to the training process. So that's where like the #1 application is, and the second one you have query and user-defined functions and so on. And to answer your second question, what is like one of our most interesting applications where we have seen so far, I think we have worked with a company called Intellinear. What they do have is that they have airplanes flying over the fields in Illinois, collecting a lot of aerial image data. And these data sets are stored on S3 and petabyte scale. And the problem they have to build computer vision models to be able to provide insights to the farmers where there's a disease on the field or dry down area. And for them to be able to take this whole data set and then train real-time machine learning models on top, like the current ways that like the whole aerial image community is working with is like 20 years old. So that's why representing the data like kind of in native deep learning or machine learning way helps them to very efficiently stream this data to even SageMaker as well to train those models and then feed the models to the production so they can provide insights to the farmers.
Hi, thanks for the presentation. My name is Diego, and I have a question regarding how this actually works. You say that the data is streamed from the database into the model that's learning. And for in deep learning, we usually run several epochs, and we use data points several times. Do you stream data several times? So if I need to run 1,000 epochs, I will stream the data sets entirely 1,000 times? Or is it cache in a smart way somehow in the server while it runs?
Yeah, that's a pretty good question. So I think one of the key achievements that we have got is that we can actually stream the data from, let's say, if you're in a local same infrastructure, let's say on same AWS region, we can stream the data from S3 to EC2 machines as if the data is like locally on the file system. So which means that even if you iterate multiple epochs on your training process, we can, as if you want, we can stream this data like as many times you want in real time. However, that's not always the most efficient way of doing things. Sometimes you want to have a cache, and we do have an in-memory cache on the edge on the computing machines, or you can also optionally cache it on a local file system if you want so.
So if there are network costs and the database is not necessarily in the same collocated with where the model is running, I would increase considerably the cost of transferring data.
Yeah, so okay. I mean, one key thing that we get is like in AWS, I don't know if you know, like if you take the data from one EC2 machine into the other EC2 machine, you actually have to pay a tax to AWS for the data transfer cost. Yeah. But if you're in the same region, the data is on S3 and directly streamed to the EC2 machine, then it's free. So you don't have to pay for this tax. So given this case, if you're in the same region, it's free. You can just overuse the resources that you get on AWS.
Thank you.